A corporation must appoint a president, a chief executive officer, a chief operating officer, and a chief financial officer. It must also appoint a planning committee with 3 different members. And there are 13 qualified candidates, and officers could serve also on the committee. Now, we have a few questions here. Number 1, how many different ways can the officers be appointed? Well, we have 4 officers. We have a president, we have a CEO, we have a COO, and we have a CFO. So there's 4 officers that need to be chosen out of 13 qualified candidates. So out of a group of 13, we're picking 4. And we want to know how many different ways can we pick those 4 officers out of a group of 13, assuming no one person could have 2 positions. So no repeats, and order matters. So for part A, and this is important in terms of determining what we should do, there's no repeats, and order matters. If you switch the president with the CEO, if you swap those 2 people, you have a different cabinet. Right? So order matters. So that tells us, for part A, it's a permutation. And so out of 13 choices, we're picking 4 of them, and it's a permutation. So 13 permutation 4. Now we have a formula for this, and we could use a calculator. So that's 13 factorial divided by 13 minus 4 factorial. But I'm going to use Excel to calculate the permutation. And on Excel, the Excel function is PERMUT. That's the permutation formula on Excel. And we have to tell Excel we have 13 objects, and we're picking 4 of them. Okay, so let me pull up Excel. Okay, we could zoom in a little bit because we don't need much room here. Okay, so, and again, you don't have to know that the permutation formula on Excel is PERMUT. Just type an equal sign, and then just start typing the word that you want to calculate. It's a permutation, so start typing the word permutation. As soon as we get 4 letters into the word, there's only 2 Excel functions that start with the letters PERM, and the first one here is returns the number of permutations for a given number of objects. That's exactly what we want. Then Excel is telling us, in parentheses, number, comma, number chosen. So out of the 13 candidates, that's the number of objects we have. The number we're choosing is 4. Right? So it looks like there's 17,160 different ways. 17,160 different ways we can pick a president, a CEO, a COO, and a CFO. All right, so for part B, how many different ways can the committee be appointed? Well, a committee is a group. There's no title to the 3 different positions. It's just a group of 3. So we have no repeats because we need 3 different people. And order doesn't matter. Order doesn't matter. So when you're choosing a group from a larger group with no repeats and order doesn't matter, that is called a combination. And so of the 13 possible choices, we're picking 3 of them, a committee of 3 members, 3 different members, so that the word different tells you there's no repeats. The word committee tells you it's a group. Okay, we have a group of 3 different members. Okay, and again, there is a formula for combinations, and that's 13 factorial divided by 13 minus 3 factorial times 3 factorial. But again, I'm not going to use a calculator for this. I'm going to use Excel, and the Excel function is COMBIN. Again, out of 13, we're picking 3. Okay, so we pull up Excel again. So if I just type the letter COM, there's only 3 functions on Excel that start with COM, and the first one looks like the one we want, returns the number of combinations for a given number of items. And again, number, comma, number chosen. So out of a number of 13 objects, we're choosing 3 of them. So 13, comma, 3. So it looks like there's 286 different ways we could pick 3 people from a group of 13 people. And finally, in part C, what is the probability of randomly selecting the committee members and getting the 3 youngest candidates? Well, there's only one group out of the 286 with the 3 youngest people. It's the 3 youngest people. So for part C, there is one possible group of 3 that consists exactly of the 3 youngest people out of the 286 possible different groups of 3. Okay, so the probability of the 3 youngest will be 1 over 286. And if you need a decimal, you could plug that into a calculator and do 1 divided by 286. But I think in this case, we'll leave it as a fraction. All right, that does it for this problem. I hope it was helpful.